Hello, and welcome to this video on specific heat capacity worked calculations for GCSE Physics and Combined Physics. The definition of specific heat capacity is the energy required to raise the temperature of 1 kilogram of substance by 1 degree Celsius. This is an example question. Water has a specific heat capacity of 4,200 joules per kilogram degree Celsius. It needs 4,200 joules of energy to increase the temperature of 1 kilogram of water from 20 to 21 degrees Celsius. The equation for specific heat capacity is change in thermal energy equals mass times the specific heat capacity times the change in temperature, or delta E, change in thermal energy, equals mc, mass, times specific heat capacity, times delta theta, which is the change in temperature. What is the energy required to raise the temperature of 0.24 kilograms of water from 20 degrees Celsius to boiling? First, we need to look at our change in temperature. 20 degrees Celsius to boiling is 20 degrees Celsius to 100 degrees Celsius, so the change is 100 minus 20, which gives us 80 degrees Celsius. Next, we need to write down our equation, which is delta E equals mc delta theta. And then we need to substitute in the information that we have from the question. We don't know our change in energy, so we leave that as delta E, and that equals 0.24, which is our mass, times 4,200, which is the specific heat capacity of water, times 80, which is our temperature change. If we then use a calculator, we work out that our change in energy is 80,640 joules. Calculate the specific heat capacity of a substance that requires 5,775 joules of energy to raise the temperature from 25 degrees Celsius to 30 degrees Celsius. The measured mass of the substance is 3 kilograms. Use the information and the answer to identify the substance. First, we need to write down our equation, which is change in thermal energy equals the mass times the specific heat capacity times the change in temperature. Then we need to substitute in our numbers from the information in the question. Our change in energy, delta E, is 5,775, and that equals our mass, which is 3 kilograms, times the specific heat capacity, which is our unknown, so we leave that as C, times by our change in temperature, which is 5 degrees Celsius, because we went from 25 degrees Celsius to 30 degrees Celsius. We then need to rearrange our equation to make C the subject. As C is multiplied by 3 and 5, then we need to divide through by 3 and 5, not forgetting to use brackets so that our calculator gives us the right answer. And that leaves us with 5,775 divided by brackets 3 times 5, close brackets. This will equal C, our specific heat capacity, and when we use our calculator, we get our final answer of 385 joules per kilogram degree Celsius. We can then use that answer to compare with our data table, and we find that our substance must be copper, as the specific heat capacities are the same. An iron block of mass 5 kilograms is heated with an energy source that transfers 10,000 joules of thermal energy to the block. If the block starts at 21 degrees Celsius, what will its final temperature be? So first we need our equation, which is change in thermal energy equals mass times the specific heat capacity times the change in temperature. Then we need to substitute in our numbers. We know that the change in thermal energy is 10,000 joules, so we can substitute that in instead of delta E. And that equals our mass, which is 5 kilograms, times by our specific heat capacity, which we can get from the data table. We know that it's iron, so the specific heat capacity is 449 joules per kilogram degree C. And that's multiplied by our change in temperature, which is our unknown. We now need to make delta theta, our change in temperature, the subject, which means we need to divide through by 5 and by 449. This gives us our next expression, which is 10,000 divided by brackets 5 times 449, close brackets, which equals delta theta, which gives us our answer of 4.5 degrees Celsius. 4.5 degrees Celsius is the temperature change of the block. The block started at 21 degrees Celsius, so the final temperature is 4.5 plus 21, which gives us our final answer of 25.5 degrees Celsius. And that's all for this video. Thank you so much for listening.